Welcome back. Let us continue solving our worksheet on complex number. The first question, simplify and find the modulus, and z is equal to given 1 minus 2i the whole square times 3 plus I. First let us square the bracket part. It will be 1 minus 4i minus 4 times 3 plus I. How comes? Remember, a minus b the whole square form. It will be a square minus 2ab plus b square form. But here, instead of plus, I made minus because the I square will be negative. So when you simplify, it will be 1 minus 4 will be negative 3 minus 4i times 3 plus I remain. Still we can expand and simplify. We are looking, or we are trying to get the z value, the simplest form. So this negative 3 will multiply each of them. It will be negative 9 minus 3i. Again, the negative 4i will multiply each of them. Negative 12i plus 4. How plus? I times I will be negative 1. So negative of negative will be plus. So the z will be simplified, and negative 9 plus 4 will be negative 5 minus 15i. This is the z and the simplest answer. But we are not asked only the simplest form. So we need to find also the modulus. So the modulus of z will be the square root of square each component, negative 5 square plus negative 15 square in the square root. This is negative 5. So this will be 25 plus 225. When you add it to 250, it will be. But 250 can be written as again 25 times 10. And it can be condensed and written as 5 square root of 10. This is the z modulus. Next question. Again, when you go to b, what is z? 1 plus I the whole the power of 2n plus 1 times 1 minus I the whole the power of 1 minus 2n. So first of all, let us try to be systematic here. Let's expand it. Remember, a the power of m plus n, it can be written a the power of m times a the power of n form. So I can write each of them in that form, and then let us try to collect having the same exponent form. So what to do? 1 plus I the whole the power of 2n times 1 plus I, the first only, and the second one again 1 minus I times 1 minus I the power of negative 2n. But when you try to observe now the middle part, these two, they are conjugate of each other. So when you multiply, it will be just 1 square plus 1 square, that is 2. So the middle part, the whole thing is just 2. No need to worry. But the ending here, the first and the last, they do have the same exponent, but this one negative, so I can bring it down. It will be 1 plus I the power of n, 2n. Let's write again. 1 plus I the whole the power of 2n over 1 minus I the whole the power of 2n. Don't forget times 2 there. This is a z. Now when you try to see the exponent, the numerator, the denominator, they are the same, 2n and 2n. So I can write this one as 1 plus I over 1 minus I the whole the power of 2n. Still times 2 is there. And then let's try to rationalize the one which is found in the bracket. When you rationalize, it's going to be, when you rationalize, the result will be, or the simplest form will be just I. How comes? You can multiply the numerator and the denominator by 1 plus I over 1 plus I, the conjugate. The denominator part will be 2, and the upper part also will be expanded and simplified, and it gives us just I. I the power of 2n, it has two possible outcomes. I the power of 2n means it will be 1 or negative 1. It depends on n. If n is even, it will be 1, and if n is odd, it will be negative 1. So our z will be 2 or negative 2. When n is even and when n is odd. That's it. So modulus of z, no need to confuse, just 2. Square root of 2 or negative 2 square, when you put it, it will be 4. 4 from the square root will be just 2. Anyways, the simplest form of the z will be either 2 or negative 2. It depends on the n value. Let us go to the next question. The next one, what we have here is 2 plus square root of negative 25 minus, there is bracket here, again another bracket, 3 minus square root of negative 216, it is 6 here, and this is square root of negative 25. Then plus, again in bracket, 1 plus square root of 9. Then close the bracket. So square root of negative 25 is the same as 5i. 25 from the square root is just 5, but it's negative, so that I will remain there. And 216, negative 216 in the square root, again it will be 6 radical 6i. 216 by itself is 36 times 6, 36 times 6, and 36 from the radical will be 6, and the 6 remain inside, and the negative, because of that, it will be I here. And this one, radical 9 is just 3, 3 plus 1 will be, obviously the whole thing will be 4. So let us connect it now. Now it's going to be 2 plus 5i minus 3, this negative will be distributed, and negative will be plus 6 radical 6i plus 4. Then the z will be, when you collect, 2 plus 4 will be 6, 6 minus 3 will be just 3. This is the real part. Plus the imaginaries are 5i and 6 plus 6 radical 6i. So I can write them together, 5 plus 6 radical 6, the whole I. This is a complex number, or the simplest form. And when you find the modulus, what to do? In the square root, 3 square plus 5 plus 6 radical 6 square. Somehow I am taking, because of the one which is found here, so it need a calculator and it can be completed. But the idea, the modulus of the z will be this one. After this, it will be simplest. So this result will be approximately 20. Next one, the next one, z is equal to I the power of 400 plus 3i the power of 200 plus 5i. So this time we need to remember I the power of 2n, 2n is even number, will give us either 1 or negative 1. It depends on n again, if n even and if n is odd. So when you are thinking of I the power of 400, it can be written as I the power of 2 times 100. As you see, the bracket part is even number, so it will be just 1. The same way, I the power of 200, this one 2 times 200, 2 times 200. And the second one, I the power of 2 times 100. Again, the bracket part is just even, so it will be 1. So both of them will be 1. So 1 plus 3 plus 5i remain. So the sum of these two real will be 4 plus 5i. This is the simplest form of the z. And then the modulus will be 4 square plus 5 square in the square root. That is 16 plus 25. When you add it, it will be 41 in the radical. That is the modulus, and this is going to be the simplest form. Next one. The next question. Three minus 2i times 2 plus 3i the whole over 1 plus 2i times 2 minus I. This is a complex number, the z given. Let us try to multiply and remove the bracket for up and down. It will be, when you expand, the 3 will multiply each of them. 3 times 2 will be 6, and 3 times 3i will be 9i. Again, negative 2i times 2 will be negative 4i, and negative 2i times 3 will be plus 6. The same way, the down part will be 2 minus i plus 4i plus 2. Then when you add the real with the real, 6 plus 6 will be 12, and 9 minus 4 will be 5i, the denominator part. 2 plus 2, 4, and negative I plus 4i will be 3i. Let us try to rationalize. 4 minus 3i over 4 minus 3i. Then the z will be, when we expand it, it will be 48 minus 36i plus 20i plus 15. The down part will be the square of the sum of each component, that is 4 square plus 3 square, so which will be 25, and the upper part will be 63 minus 16i. So we can write it in the standard form, x plus yi form. That's going to be the simplest form of the z, that is 63 over 25, this is the real part, minus 16 over 25, I is the imaginary part. Then the modulus will be the square of each component in the square root, that's going to be approximately 4. The last one for the first question, 5i the power of 72 minus 1 the whole over I the power of 23 plus 5. Again here, I the power of 72, it can be written, since it's even number, I the power of 2 times 36, and 36 is even number, so the outcome will be just 1. So the upper part is only 4 minus 1 remain. Let us think of the denominator part. I the power of 23, it can be written as I the power of 22 times I, and the 22 part I the power of 2 times 11 times I remain. And since this number is odd number, it will be negative 1. Negative 1 times I will be just negative I. So it will be negative I plus 4. So this one I can write it 3 over 4 minus I 4. Then rationalize. When you rationalize, you'll multiply by 4 plus I over 4 plus I, which is 12 plus 3I the whole over 16 plus 1. This is equal to 12 over 17 plus 3 over 17i. This is the simplest form, and the modulus will be the square root of 12 over 17 square plus 3 over 17 square, the whole thing in the square root, and this will be approximately. So we need to correct some silly mistake here. The upper part, we don't have to exchange the place. This is 5, and I the power of 23, we got it already, negative I, so negative I plus 5 will be 5 minus I, and the upper part I the power of 72 will be just 1. We said 1 times 5 will be 5, 5 minus 1 will be 4. So what we have, 4 over negative I plus 5 will be 5 minus I. So the conjugate of 5 minus I will be 5 plus I. So we'll multiply both the numerator and the denominator. So when you multiply, 5 times 4 will be 20, and 4 times I will be 4i. The lower part is the sum of the square of each component, that is 25 plus 1, that is 26. So 20 over 26 plus 4 over 26 in the I. This is a z. When you simplify each of them, you can simplify by 2. 10 over 13 plus 2 over 13i, that is the simplest answer. But since we need to find the modulus also, we will square each of them in the square root and add it. 10 over 13 the whole square plus 2 over 13 the whole square. Approximately it will be 0.78. Next question, find the polar form, it says. First, what's A? The first one, the z is equal to 1 plus square root of 3i the whole over square root of 3 plus I. So we can find the r and the theta of the upper and the lower edge, and then we are going to write each of them polar form, and then we'll simplify. Let's do it. So the numerator part only, the r will be square each component 1 square plus radical 3 square. You know, radical 3 square is 3 plus 1, that is 4, from the square root will be 2. And the lower part also the same, radical 3 square plus 1 square will be square root of 4, that is 2. Each of them r is 2. And the theta, tan inverse of, you know, y over x. The y is imaginary and the x is the real part. So radical 3 over 1 means radical 3. So tan inverse of root 3 will be 60 degree, and the lower part, the theta, will be tan inverse of 1 over root 3. Therefore, the given complex number, we can write it 2 times the upper part only, cosine of 60 plus I sine 60, the whole over the lower part again 2 times cosine of 30 plus I sine 30. Then this time we can cut the 2 here and then subtract the angle. Cosine of, you know, 60 minus 30 will be 30 plus I sine, again 60 minus 30 will be 30. According to the rule, if it is once written in the quotient form, you can subtract the angle and you can simplify the r's. So this will be the polar form of the first one. Let us go to the second part. The second part, first let's write the given z. Z is equal to cube root of negative 125. This is the same as negative 5, you know, obviously, plus square root of negative 25. Again, this is the same as 5i, the whole over I the power of 59. First of all, we need to know what means I the power of 59. This we can write it I the power of 58 times I. Again, this one 58 will be I the power of 2 times 29. Since times I there, 29 is odd, so this thing, the whole thing will be negative 1 times I, that is negative I. The lower part only negative I. And the z will be now, the upper part is negative 5 plus 5i, the whole over negative I. We do have this. So the numerator part only, the r will be negative 5 square plus 5 square, that is 25 plus 25 in the square root, which is 50. 50 can be written as 25 times 2, you know, in the square root, and 25 from the square root will be 5 root 2. And the theta, tan inverse of, you know, 5 over negative 1 will be negative 1, but its negative positive will be in the second quadrant, so the related angle will be 135, because if it is just positive both, it will be 45 degree, but second quadrant, the related angle for 45 will be 135. And the lower part, the r will be just 1, because this means 0 minus, you know, and the theta will be this 0 comma negative 1 is in the fourth quadrant in the y-axis, that's quadrantal angle, so the theta will be negative 90. Therefore, the z can be written 5 root 2 in bracket cosine of 135 plus I sine 135, the whole over, you know, 1 times just cosine of negative 90 plus I sine negative 90. So we'll subtract the angle. When you minus, it's going to be added. So finally the z, the complex number form of the z will be 5 radical 2 cosine of, when you add it, it will be, because the negative of negative will be added, 2 to 5 plus I sine 2 to 5. We don't have to forget the bracket here, and the r is outside. This is a complex number, the polar form of the given complex number. Let us go to the next one. The next question, the z is equal to negative 5 root 2 over 2 plus 5 radical 2 over 2i. So this one just directly, first let's find the r and then the theta. The theta, it is like we said, positive, negative, they are the same. 5 root 2 over 2, 5 root 2 over 2, it will give us 1. So it's tan inverse of negative 1, that is 135 degree in the second quadrant, because positive negative is in the second quadrant. Let's get the r. The r will square each of them. So when you square this one, negative 5 square is 25, and radical 2 square will be 2, and 2 times 25 will be 50. Here it is, and the down part just 4. The same way the second part. So when you add, it will be 100 over 4. From the square root 100 is 10, and from the square root of the 4 is 2, and 10 divided by 2 will be 5. So I have everything now. We can find the z, which is 5 in bracket, cosine of 135 plus I sine 135. Next question, change the following into Cartesian form. This time we need to find the trigonometric value of the given angle. So what you can do when you try to see the angle, the theta here, it is 2 over 3 pi. This angle is greater than pi over 2. It is in the second quadrant. So what we can do, since it is in the second quadrant, to know the related angle, we will make pi minus 2 over 3 pi. When you subtract by crisscross, pi times 3 will be 3 pi. 3 pi minus 2 pi will be just pi over 3. Pi over 3 means 60 degree. So you can write it 5 times negative cosine of pi over 3. Why negative here? Because it's second quadrant. I said in the second quadrant cosine will be negative, plus I sine pi over 3, but sign will not be changed. Remember, in the fourth quadrant, ASTC rule, the second quadrant sign is positive. So the angle is in the second quadrant. This angle is second quadrant. That's why I apply this rule. Then this is equal to 5 times cosine 60, it is negative 1 over negative radical 3 over 2, plus sine 60, cosine 60 is 1 over 2, so negative 1 over 2, plus sine 60 will be radical 3 over 2i. So when you finalize, it will be negative 5 over 2. Let's write it properly. Let's use the space here. The z is equal to negative 5 over 2 plus 5 radical 3 over 2i. This is the Cartesian form of the given complex number. Next one, we have the r and the theta. R is equal to 5 and theta is equal to pi over 3. So the z will be 5 cosine of pi over 3 plus I sine pi over 3. As I said before, pi over 3 is 60 degrees, so 5 cosine 60 is 1 over 2 plus I sine 60 is radical 3 over 2. So when you finish it, 5 over 2 plus 5 radical 3 over 2i. That's going to be the rectangular form. And the last one for the third question. First, let's write it. The z is equal to 12 in bracket cosine of 10 over 9 pi plus I sine 10 over 9 pi, the whole over 3 times cosine of 35 over 18 pi plus I sine 35 over 18 pi. what am I going to do here? I will simplify the r. 12 divided by 3 will be 4. Z is equal to 4 times cosine of, I'm going to subtract the angle, or minus the upper angle minus the lower. The same thing I will do for the sine and the cosine. And what will be the result? So what will be the difference when you minus 10 over 9 pi minus 35 over 18 pi? What to do to make the denominator the same first? You can multiply by 2 by 2. So it will be 20 pi. 20 pi minus 35 pi will be the pi here up. It will be negative 15 over 18 pi. When you simplify by 3, negative 5 over 6 pi. So for each of them, here it is. Then this negative has no effect for cosine because it's even function, cosine of 5 over 6 pi. But this negative has effect for sine because it will be odd function. It can be taken out and it will be a coefficient here. So negative I sine 5 over 6 pi. Again, 5 over 6 pi, it's a second quadrant angle because it's greater than pi over 2 or 90 degree. So to know the related angle, the theta related would be pi minus 5 over 6 pi. So it will be pi over 6. Pi over 6 means 30 degree. But cosine still it's negative second quadrant. So the z will be, let us use another color. The z will be 4 times cosine of 30 degree will be radical 3 over 2, but I will make negative. The reason it's a second quadrant angle, minus, this is already minus, but sine of second quadrant angle has no effect, so the sign will not be changed. Sine of 30 is 1 over 2i. So the z will be, when you simplify, negative 2 radical 3 minus 2i will be the simplest answer. What is given here? Z1 2 plus I, and Z2 is equal to 3 minus 2i, and D3 is equal to negative 1 plus radical 3i the whole over 2. And then what's asking? A, Z1 cube minus 3Z2 plus 4D3. These two are easy, just multiplying by the constant. But Z1 cube, let's get it. Z1 cube means the same as 2 plus I cube, which is 2 plus I square times 2 plus I. 2 plus I square alone will give us 4 plus 4i minus 1 times 2 plus I. So this is the same as 3 plus 4i times 2 plus I again, because 4 minus 1. Then again when we expand, it will be 6 plus 3i plus 8i minus 4. This is the same as 2 plus 11i. So this is the whole thing is the first part only. So let's write it now. When you connect it, 2 plus 11i minus 3 times what is Z2, 3 minus 2i, plus again 4 times in bracket negative 1 plus radical 3 the whole over 2. There is I here. So what I can do here, I can simplify by 2. This will be 2. So 2 plus 11i, let's use our space properly. 2 plus 11i minus 9 plus 6i. These two will multiply each of them. Minus 2 plus 2 radical 3i remain. This is equal to, now let's collect the real parts. 2 minus 2 will cancel each other. So what remain? Negative 9 remain. These two and negative 2 cancel each other, and negative 9 remain in the real part. The imaginary part, 11i plus 6i will be 17i, and there is also another i's here, but they are not like terms, so you cannot add. So I can write plus 17 plus 2 radical 3 the whole I. That's going to be the simplest answer. So the rest question also will be done in that pattern. The next one, for example, if you see B, it says that 3 the power of 4 the whole conjugate, it says. So what to do? You're going to multiply the Z3 4 times, and then you are going to take the conjugate of it. So the same pattern it will be continuing. The last question for today, what's given here? F of z is equal to z square minus 4 over z. Then what's asked? F of 1 plus I is asked. What am I supposed to do here? Since we need to find f of 1 plus I, what I will do, in place of z I will write 1 plus I everywhere. So f of z is equal to z square minus 4 over z. So when I say f of 1 plus I, this 1 plus I can be considered as z. So z square minus 4 over z form. Then when I square this part, it will be 1 plus 2i minus 1 remain, minus 4 times 4 over 1 plus I can be multiplied by the conjugate 1 minus I over 1 minus I. Therefore f of 1 plus I will be here 1 and negative 1 cancel, and what remain? 2i remain, minus 4 times 1 minus I the whole over 2. Here when you multiply these two, 1 plus I times 1 minus I will be 1 square plus 1 square, that is 2. Then we can simplify by 2 1, this by 2 2. So what left? 2i, these two will multiply now each of them, minus 2 plus 2i. So what left? Negative 2 plus 4i. That's going to be the simplest answer, because 2i and 2i will be added. Both of them are imaginary. So that will be the final question for this video. Don't forget to subscribe, like and comment, and also share to your friends. Thank you for watching.